LDA. Linear Discriminant Analysis. LDA. In machine learning. AI intermediate level. Introduction. Many machine learning datasets contain multiple features, making it difficult to visualize or analyze patterns in the data. Reducing the number of features can simplify the dataset and improve model performance. One method used for this purpose is linear discriminant analysis. LDA. LDA is a dimensionality reduction technique commonly used for classification problems. It reduces the number of features while maximizing the separation between different classes. LDA is widely used in applications such as facial recognition, speech recognition, medical diagnosis, marketing analytics, financial risk prediction. Understanding LDA helps learners build efficient classification models and better feature representations. What is LDA? Linear Discriminant Analysis. LDA is a dimensionality reduction technique that projects data into a lower dimensional space while maximizing the separation between classes. In simple words, LDA equals reducing features while making different classes easier to separate. Example concept. High-dimensional dataset means LDA means better class separation. The goal of LDA is to find directions in the data that maximize class separability. Why LDA is important? In classification problems, features should help distinguish between different classes. Example concept. Overlapping classes means difficult classification. LDA helps by transforming the dataset so that classes are more separated. Classification becomes easier. Models perform better. This improves machine learning performance for classification tasks. LDA versus PCA. LDA is often compared with another dimensionality reduction method called principal component analysis. PCA. Method goal. PCA preserve maximum variance. LDA maximize class separation. Example concept. PCA means variance preservation. LDA means class discrimination. PCA ignores class labels, while LDA uses them to improve classification. How LDA works. LDA works by projecting the dataset onto directions that maximize the separation between classes. Example concept. Dataset means projection means improved class separation. The algorithm attempts to maximize between class variance, minimize within class variance. This ensures that different classes are far apart while samples within the same class remain close. Between class variance. Between class variance measures how far apart the class centers are. Example concept. Class centers means large distance means better separation. LDA tries to maximize the distance between class means. Within class variance. Within class variance measures how spread out data points are inside each class. Example concept. Class samples means tightly grouped means smaller variance. LDA attempts to minimize the spread within each class. LDA projection. LDA finds the optimal projection direction that maximizes class separation. Example concept. High-dimensional data means projection means discriminant axis. Data is projected onto this new axis to create a reduced feature space. Number of LDA components. The maximum number of components produced by LDA depends on the number of classes. Example concept. Maximum components equals number of classes minus 1. For example, 3 classes means maximum 2 components. 4 classes means maximum 3 components. This limitation ensures that LDA focuses on class discrimination. LDA workflow. A typical LDA workflow looks like this. Dataset. Down pointing arrow. Compute class means. Down pointing arrow. Calculate scatter matrices. Down pointing arrow. Find optimal projection directions. Down pointing arrow. Project data into reduced space. Down pointing arrow. Train classification model. This process simplifies the dataset while improving class separation. Advantages of LDA. LDA provides several benefits. Advantages include: improves class separation, reduces feature dimensionality, improves classification performance, reduces computational cost. Example concept: better class separation means improved classification accuracy. These benefits make LDA useful for many classification tasks. Limitations of LDA. Despite its advantages, LDA has some limitations. Limitations include: assumes linear relationships, assumes normally distributed features, sensitive to outliers. Example concept: nonlinear data means LDA limitations. In such cases, other techniques may perform better. Example Python code. LDA can be implemented using scikit-learn. Import LDA from sklearn. Discriminant_analysis. Import linear discriminant analysis. Apply LDA. LDA equals linear discriminant analysis. n_components equals 2. x_reduced equals LDA.fit_transform. X, Y. This reduces the dataset to 2 discriminant components. Real-world applications. LDA is widely used in AI systems. Facial recognition. Reducing face image features while separating identities. Medical diagnosis. Separating disease categories based on medical features. Marketing. Classifying customers into behavior segments. Finance. Risk classification models. Speech recognition. Classifying audio signals. Concepts learned from LDA. Understanding LDA helps learners understand. Checkmark how dimensionality reduction works for classification. Checkmark how class separation improves machine learning models. Checkmark how between class and within class variants are used. Checkmark how LDA differs from PCA. Checkmark how feature transformations improve classification accuracy. LDA is a powerful method used in classification-based dimensionality reduction. Simple definition. Linear discriminant analysis. LDA. A dimensionality reduction technique that projects data into a lower dimensional space while maximizing separation between different classes. Final summary. Linear discriminant analysis, LDA, is a powerful dimensionality reduction technique used primarily for classification tasks. Unlike PCA, which focuses on preserving variance, LDA focuses on maximizing class separation. By projecting data onto directions that maximize between class variance and minimize within class variance, LDA improves classification performance and reduces feature dimensionality. Understanding LDA is essential for building efficient classification models and interpretable machine learning systems.